Hello and welcome to Introduction to Optimization, Exercise Class 5. In this class, we will learn how to formulate and interpret dual problems of optimization problems. We can use the rules from the following table to form the dual problem from the primal problem and vice versa. In our first demo, we will formulate two linear optimization problems and then compare them. In the first linear optimization problem, Jeff wants to make a meal which minimizes his costs and satisfies his protein and calcium requirements with the foods and their prices and unit quantities of protein and calcium listed on this table. In the second linear optimization problem, a pharmacist wants to make protein and calcium tablets that maximize his profit by charging the highest possible prices to satisfy Jeff's protein and calcium requirements while not exceeding the costs of the listed foods. We'll start by color coding the parameters as seen on this table. We will also color code the minimum requirements for protein and calcium. We'll continue to formulating the Jeff's problem. We will define the decision variables as follows. x1 is the quantity of potatoes, x2 is the quantity of tomatoes, and x3 is the quantity of milk. Then Jeff's objective is to minimize the total cost of the meal as formulated here. The constraints of Jeff's problem are set by his daily requirement for protein and calcium. Here both the total amount of protein and calcium from his meal must exceed the levels given in the problem, and also the quantities cannot be negative. The solution for Jeff's problem yields the unit quantity for potatoes as 9.21, tomatoes 0, and for milk 2, with the minimum cost of €10.08. Next we will formulate the pharmacist's problem as described in the problem description. In the pharmacist problem, we will set the decision variables such that the U1 is the unit price of protein and U2 is the unit price of calcium. Then the objective will be to maximize the total profit from the substitution tablets as formulated here. The constraints will be set such that the substitution tablet's price cannot surpass the price of the real foods as formulated here, and also the unit prices are non-negative. Then we'll obtain the following solution where the unit price for protein is 0.138 and the unit price of calcium will be 0.004 with the maximum profit of €10.08, which is the same as for Jeff's problem. Now by comparing the Jeff's problem with the pharmacist's problem, we can see that it is the dual of the pharmacist's problem and vice versa, and that's why the solutions had the same value. And here is the pharmacist's problem.